Example 13 corresponds to example 5K, back when we did example 5. Suppose you want to buy a new car and you decide to save up for the car instead of taking out a loan. What amount should you deposit at the end of each month for 3 years in a savings account earning 4.5% interest compounded monthly to accumulate the $18,000 needed to buy the new car? Okay, so again, always read through the problem, make sure you fully understand what's going on before attempting to solve it. Okay, so what's going on here is you're trying to buy a new car. Instead of taking out a loan, you decide to save up for the car. Okay, and you're going to save so much money at the end of every month for a 3-year period, and then let that money grow through your deposits and the interest, and you're hoping to have $18,000 saved up for the car at the end of the 3-year period so you can buy your new car with that money. Okay, when we looked at this in example 5, if we flip back to that, let's see where that was. Like I said, it's 5K. We labeled this as a future value of an annuity problem. Okay, and again, if you look at the box here, what I had boxed here, you're depositing money at the end of every month into your savings account. Okay, so you're saving money through regular deposits. So that's what made this problem a future value of an annuity problem. Okay, so let's go ahead. I'll notate that on here as well. So we're depositing money at the end of each month. So saving money, regular deposits. Okay, and because of that, we will be using this formula, future value of an annuity. Okay, all right, so let's figure out what we're given, what we're looking for, and then we can plug everything in and solve. Okay, so let's see here. Let's do the obvious stuff first. We know the interest rate is 4.5%, so that's going to be 0.045. Okay, we're compounding monthly. Okay, so remember, however often the interest is compounded, that will coincide with how often you're making a deposit. Both things will be monthly here. The interest will be compounded monthly, and you will be making monthly deposits. Those things will always coincide. So ILM is going to be 12 here. Okay. Time, the money's being saved for a 3-year period. Okay. So now we're just left with A and P. Okay, so one of those we know and one of those we don't know. Okay, so again, with this formula, P is the amount of the periodic deposit, okay, or the regular deposit. A is your account balance. Okay, so what's going on here, if you look at the question says, what amount should you deposit at the end of each month? Okay, so you're trying to figure out how much your regular deposit is each month so that you can come back in 3 years and have an account balance of $18,000. Okay, so the account balance A is going to be $18,000. You're looking for the P value, or the amount of each deposit, each monthly deposit, in order to save for the car in this manner. Okay, so let's go ahead and plug everything into our formula. Okay, so I'll go ahead and do that over here. All right, so we are solving for P. All right, so this is what it should look like once you get everything in. All right, and again, in the denominator, make sure you realize that everything is divided by R over M. Okay, all right, so here we go. So we are solving for P, okay? So again, when you look at this formula, P is multiplied by all this stuff in the brackets, okay? We could actually go to our calculator and punch in the stuff that's in the brackets to figure out what P is being multiplied by, and that is what we're going to do. Okay, so remember what I told you in the last example. When you're punching this formula into a calculator, you want to start with the most complicated part first, okay, and then work from there. Okay, so if we're going to enter in the quantity that's in brackets, okay, the top is definitely more complicated than the bottom. Okay, so we're going to enter the top into the calculator, get that number, and then once we have it, we can divide by the denominator. and then we will have the quantity in brackets, and we can figure out that's what P is going to be multiplied by, and then we can go from there, okay? So let's go to our calculator and try to get this quantity that P is being multiplied by, okay? So if we go to the calculator, okay, start, we're working with the stuff in brackets, start in the numerator, so open your parentheses, 1 plus 0.045 divided by 12, close parentheses, raise it to the power, okay? You can do the exponent in your head if you choose to, or if not, just make sure you put it in parentheses if you need them. So 12 times 3 is the exponent, okay? You need to get out of the exponent before subtracting the 1, okay? If you left that -1 in the exponent, it's not going to come out correctly, okay? Hit enter. That is the numerator of the quantity that is in brackets, okay? Now we need to divide by the entire denominator, so hit the division key, okay? So we'll just, that keeps you from having to re-enter that decimal, okay? Again, no rounding at this point, okay? So let's divide by the entire denominator. You need parentheses here. It's a must, okay? So divide by R over M, close parentheses, okay? This is the quantity in brackets. This is what P is being multiplied by. Okay, so let's go jot that down, and then we can go from there. Okay, all right, so this is telling us that 18,000 is equal to P times, we just figured out that the quantity in brackets is 38.46608859. Okay, and again, we're solving for P, the amount of our monthly deposit, okay? So if we want to get P by itself, since P is being multiplied by this number, we just need to divide it off, okay? And then whatever you do to one side, you have to do to the other, okay? No rounding here. Remember, you've got to carry all the digits, okay? So now on the right side, this number will cancel with this number. We will be left with P on the right, okay? We're going to go to our calculator and do 18,000 divided by this 38.46 blah, blah, blah number, okay? All right, so here we go. When you get to your calculator, you can go ahead and just do the 18,000 divided by, and remember, you can enter all the digits in again if you wanted to, or you can call up the previous answer by doing the minus key, okay? And that will take the 18,000 and divide by this 38.46608859 number, okay? Hit enter, okay? And there is your final answer, okay? So this number that's coming out, this is the amount that you need to put into your savings account every month to save up for the car. So this is going to be a dollars and cents amount. So you do need to round appropriately, okay? So let me jot this down, and then we will round. All right, so here we go. Okay, the amount that you need to save every month. We've got $467. You've got 94 cents. Look after the 4. You have a 4, so you want to keep it the same. So 94 cents. Okay, this is the amount that you need to put into your savings account every month. Okay, and then between those regular monthly deposits and the interest that accrues for the 3-year period, you will earn $18,000 to go buy your new car. Okay, all right. So now what we're going to do is we are going to jump to the next example, 14. Okay, example 14 is related to this particular problem. Okay, what's going to happen is in example 13, we figured out that we could save $467.94 every month for 3 years. And between those regular deposits and the interest, we would, accrue the $18,000 needed to go buy our car. Okay. In example 14, we're going to suppose that this monthly savings plan was out of reach for us, that we couldn't swing saving $467.94 a month. We could only afford $200 a month. We could only put away $200 a month. Okay. And if that were the case, how long is it going to take us to save for the $18,000? Okay. So that's going to be the little twist on this problem in the next example. Okay, it will also be our first time we're going to solve the future value of an annuity formula for time. Okay, so let's take a look at it.